It's so awkward. I have to hold the mic?
Nope. That's your mic there. You don't have to do anything.
I was just
We're good?
like, everybody loves somebody. Dean Martin, you know?
I've got 1 minute.
Everybody clear the room, you know?
It's like in the times of the
Everybody get your Final Jeopardy, right?
15. Okay, it is 12:45 according to the electronic wall over here, so we're going to get started. I want to welcome back Rich Grumm, who has been a great friend of the department and bringing these presentations to us, these weekly briefings. Between Rich and a few select others, I can always rely on at least 1 or 2 volunteering shifts per semester, and we appreciate that. Rich is the SU at the National Weather Service office here locally at CTP, if you're not familiar. And for undergraduates that are here, I highly suggest looking at his website, which he'll show repeatedly, I'm sure, in the upcoming presentation, at some of the case studies. Especially when we have events like we just went through yesterday. Rich gets these case studies put out pretty quickly after an event, and you can learn a lot about pattern recognition and how to forecast these things, hopefully days in advance. So I want to welcome Rich back, and also I want to make mention we have a special guest here, Bruce Budd from the National Weather Service office as well. He's the lead at the office currently, but he is retiring tomorrow. So that's correct, right? Tomorrow's your last day. Yeah. So we appreciate all that Bruce has done for the department and, of course, for the office, too. It's been a great relationship between Penn State and the CTP office, so I appreciate that. And, Rich, let's take it away.
Every day, every weekend is going to be a weekend. 7 days a weekend. This is a really good picture to have set up that Dan started because this really good long loop kind of shows the weather. We're going to review some of the weather that occurred this week, and you can see the big mesoscale convective system that affected the Florida Panhandle and produced the record rainfall, washed out the roads, and caused all the flooding. It doesn't quite go far enough back up to see all the severe weather we had earlier this week. And then it shows the plume of moisture and the rainfall that came up the East Coast. So I hit the wrong one. That shift tab is a good thing to know. So this is the semester-ending weather. So it's not. It doesn't imply the weather's going to end the semester, though. Maybe Godzilla's coming. We'll talk about some of the significant weather events that occurred this week. We had that significant severe weather event. It was mainly 2 really good days of severe weather, and we had a pretty long stretch actually where nobody was killed or we had like any EF3, EF4 tornadoes. It was one of the really long stretches. There's some controversy whether it was a record that, but I think it actually was not, according to Greg Garvin from the SPC. It might not have been a record, but we had a pretty long span without any really deadly weather or any really strong tornadoes. I guess it was sometime back in November it had been. So we only had one really big severe weather outbreak, I guess, this winter of note. But anyway, we'll talk a little about the flooding in Florida, and it was a dramatic QPF bust. I want to apologize in advance. I have comparisons of the GFS, the SREF, and the GFS, and I didn't change my label, so they all say GFS, but it'll be GFS, SREF in the middle, and GEFS, the forecast for the QPF. We'll look at the forecast that one for Florida. It's horrible, and we'll look for the forecasts that were on the East Coast from the ensembles, and the GFS is a guide. And then, so we'll talk a little about the rains on the East Coast. Most of the heavy stuff missed us, and what's to come for finals week and all the frills that go with that. So this is the severe weather event. This is the severe weather for the 27th, and you can see pretty good extensive outbreak from Iowa all the way back into Texas. And it was about 247 reports, which, in my experience, that's just kind of a mundane severe weather event, But this next day they had about 314 that moved into the Gulf Coast area, and anybody who plays with GR2 animals probably was killing their arm and their wrist to look at this. And then this was yesterday. It was not much left, and we'll see why. We had a really strong blocking high to our north and east, and we were called our dam that really killed the ability to get instability, at least surface-based instability in the United States. But there was some action, as you can see, in the Carolinas, and still some residual stuff that had occurred overnight with that heavy rain in Florida. So I'll just review that one more time. You can see the progression of the severe weather. So this is the rainfall of the southeast. This is a 24-hour total from the 12Z on the 29th and 12Z on the 30th. And you can see it was extremely high amounts of rain in this thing, over 150 millimeters. You can see there's contours of 250 in there, over 10 inches. This is gridded precipitation data. And most of the heavy rain, you can see the frontal system to the north that had some rain in. And I filtered out anything under 5 millimeters because I want to focus a little bit on the higher amounts. And if we zoom into Florida, you can see there was some really intense amounts over Florida. We have over 350 millimeters in the panhandle of Florida. This was the MCS that we saw on the introductory IR loop. And most of Florida was actually kind of dry, but the panhandle was extremely wet, as you can see. So, and this is the rainfall along the East Coast. This is a different data set because the data that I used to make other images isn't all processed yet. So, you can see there was a good 4 to 5 and maybe some embedded 6-inch rainfall amounts that went from Lancaster County, in our county one area, up into the Philadelphia area. I think I know that maybe 4 points went above flood stage. And I know we had 2 and 1 pending. And I know, like, on the Schuylkill River, they had problems in the Philadelphia area. So it was a pretty good rainfall event. And if anybody was following the forecast, the NSEP GFS was forecasting the heaviest rain. You can see sometimes it was like a convective bullseye because it was like a 55-kilometer forecast system. It kept having a bullseye of like 5 inches of rain over a 48-hour period over the DC area. So it got the region of the world right. It just didn't get the location right. We kind of expect that, I guess. So these are the forecasts, and I apologize again. The single solutions, of course, are the GFS. The middle ones are the SREF, and then the ones on the far side are the GFS. And then the GFS, it's just the amount of precipitation. You can see it was a pretty good 75 to almost 100 millimeter QPF forecast up in Georgia in this first set of runs. This is 0Z to 27th, and then that's 3Z to 27th, that's 0Z to 27th. I picked an SREF one that kind of fit in between if I could. And the bottom is on the 28th, and then a 3Z from the SREF. And they said it was going to rain down there, but when you're looking at a 40-50% chance of 25 millimeters or more rain, or 50, that's actually 50. The probabilities are for 50. The contours are every 25. 40 to 50% chance of 25 millimeters of rain, you get like 500 as a problem. And the GEFS had a closed 75 millimeter contour times. But you can see none of our major forecast systems really knew what was going on. I picked a shorter term window, and I was actually doing this today, and I forgot that my labels are manual, and I didn't change the code, so the labels on the model names are wrong on some of them. But you can see the shorter range forecast didn't do much better at the bottom here. In fact, it focused the heaviest rain in the GEFS and the SREF up in the Georgia area. This was the pattern over the week, and you can see the main player. You can see on that satellite image was the main player was this. In the end, would be this really deep trough. At times, it was -3 to -4 standard deviations below normals that chugged across the country. And of course, that opened up the Gulf of Mexico, which is a pretty juicy place. And we had this really deep cutoff low that was just stuck because we had this blocking ridge to the north and east, and we had a ridge developing on the west coast. So we had some pretty sharp ridges in this big trough. And this just kind of shows the progression over time of how the system moved across the United States. So this was the period in here with the first day of severe weather and the second day of severe weather. I didn't process the data yet for May 1st. But you can see this really big trough how it came barreling across the country. And if you look at the jets, you can see there was a pretty strong jet that moved up, kind of a classic jet on the front side of the trough that's moving through the area, really strong 250 hectopascal jet. If we zoomed in more locally, and we start here on the 0Z to the 27th, and we end on 12Z to the 29th, this first set, you can see in the plains at 0Z on the 27th, we got a pretty good low-level jet going, and it came out to the plains with it pretty close to maybe the severe weather was down through here, and you can see this pretty strong low-level jet with like 2 to 3 standard deviations above normal southerly flow over the area. It actually peaked on the winds got stronger, and the anomalies got to about 4 standard deviations above normal, and that's pretty close to where some of the really deadly tornadoes were. So we had a lot of low-level wind shear, and it's really strong low-level jet that came through the area, and then finally started moving up through our area on the 29th. And this is the moisture that associated with that system. You can see there was a pretty good surge of moisture that came up into the eastern plains and right up all the way into like Minnesota and Dakotas, and there was a nice moisture boundary here later in time that was the setup probably for the plume of moisture that just fed into the rainfall in Florida. And at the surface, there was a pretty deep low at the surface, at least initially, on the edges of this domain that I picked. We're looking at -3 to -4 standard deviations below normal surface pressures. That low struggled to move into that big blocking high that was to our north and east, which kept us cold air damming. And the cold air damming pretty strong here. I guess when it was raining here at my house, I couldn't get out of the 40s for 3 days. I don't know, what was the high temperature here during a period of time? Maybe 49, 50.
Yeah. 52 was the highest.
And when it was raining, my temperature was falling down to like 44. I think one day it was really horrible. It was 42 to 44. It was a really horrible day. But you can see that it was a pretty deep trough, and then this blocking high just kind of set the beautiful flow up. And this probably kept stable air over the eastern United States, really limited the eastern extent of the severe weather part of the event at least. But it created a nice overrunning boundary for the focused heavy precipitation along the east coast. I just moved in to show the eastern phase a little better. You can see how that high was so reluctant to retreat. And at times we had we had sea level pressure anomalies that were pushing 3 to 4 standard deviations above normal, really strong high, and you can almost in your head mentally see the ageostrophic winds. We were going to be east northeast. So, but the stalled boundary probably along the Florida coast was. Data, which this, as you can see, there was a and that surge came up the east coast, and it was a very narrow ribbon focused on the east coast, mainly east of here, of course. So I had about an inch at my house over 2 days. I guess I heard. What did you say again? I had about 0.8 here over 2 days. 0.8, 0.9. Yeah, but there were reports in Lancaster County and radar estimates over 5 inches of rain. So, but a nice narrow moisture plume over that cold air damming, and you can see the low-level jet was pretty good, showing almost like a synoptic type event, if you will, for the heavy rain here. There's some strong low-level winds coming into Florida early on in this event, but I guess it was really mesoscale and convectively driven, so I don't see nothing jumps out and smacks me other than the fact it was a lot of precipitable water. It was stuck there for probably 18 hours, and it was really strong winds, and our models clearly had a serious issue forecasting that. So here's the QPF that was forecast for us, and the QPF forecast, this is a forecast from the 28th, actually the evening hours. You would have seen this on the 27th. And it actually had 4 inches of rain pretty close to us. That was a pretty horrible forecast. And finally, I'm going to talk about this panel up here. This is the Gfs Accumulated Precipitation. And it finally began to shift it to the east. And the SREF and the GFS moved the precipitation further to the east. And there was actually a closed 70 millimeter contour in the GEFS. So overall, we had a deep trough with strong dynamics. We had a big moisture surge, a big severe weather event early in the week, and then a big rainfall event. And we had this late season massive anticyclone that kept us kind of cold air dammed but I guess we could say at least 3 days. And so this big anticyclone probably made us a little bit cooler than we all wanted to be, and probably kept a lot of people from doing some nice outdoor activities. But it was nothing like what happened to our south and west. And there was a major QPF bust, I think, both here and clearly in Florida. It was an unbelievable bust. It doesn't get any worse than that. I mean, when your models are forecasting 2 to 3 inches of rain and you're getting 20 inches of rain, you have a problem. So any questions about what happened this week or anything else people noticed?
Rich, do you think the errors in the QPF here, PA and the Mid-Atlantic, are more about the wrong position early on of the upper level low? You mentioned before predictability of lows is much less than predictability of highs. Is that more of a problem than the QPF, or are they both related?
I looked at the mass fields, and I don't think the mass fields look all that bad. But the details of where the QPF fell clearly was not very good. I guess I didn't realize how narrow the cold air damming would be and how the forcing would be so focused. But I've noticed over time, like that when I look at day 3 on and beyond QPF, I just kind of mentally Bayesian correct the QPF. Whatever number I see, I at least multiply by 0.7 because if I go with what I see where I see it, I'm going to get clocked. But there was a placement issue, and there was obviously some convective response issues. But I really didn't look in the details to see how bad and what the spread was amongst the members for the pattern, but the general pattern looked fairly well predicted, but the details clearly were wanting. And the QPF in these models is usually pretty bad, and they're pretty wet as you get longer in time. Yes?
Early in April, was on the Lake Charles sounding one night, was reciprocal water was like one of the highest ever observed. In April, Lake Charles since 1948, and the highest observed that early. Maybe, you know, it's patterns, kind of there, kind of off.
I think I looked at that event. I think the principal water anomalies, they were pushing 5 standard deviations. This thing was only like 3 to 4, I think. But, no more questions? Any more comments or any observations?
There's also a lot of extraordinary amount of lightning with that.
MCS?
Yeah. Just a tremendous amount more than average.
The one over Florida.
Yeah.
So is the essence here that you had a high cape, high moisture flow hitting a front that just did not move?
Yeah,
So
probably.
it just kept train echoing
Yeah.
across the place?
And in that low-level flow, that if you almost could imagine the Corfiti vectors, it was a good back-building type event over Florida. The way the winds were coming in, the coast was here, and the winds were coming in like this, and that front was still, and the moisture just sat there for like almost 18 hours.
So this really, how bad an event like that is how slow the front moves. Because if that front had been moving at 5 miles an hour, you would have spread the thing out, or if it had been moving 10,
Yeah.
it would have been spread. You know, a lot of places would have had an 8-inch rain or a 4-inch rain if it had been a modest frontal motions. But it's just not.
Which tells you the blocking to our north and east was important because it slowed the whole frontal system down. It was that massive anticyclone. It was a very deep anticyclone. It was really a critical player in the whole event. Yeah, it's really tragic that to think that we had no models that really could get the QPF even close. It's like we have a long way to go.
I've seen events like that over Christmas, where front stalls and it rains, but it sits for 6 hours and rains and thunders heavily, and then a wave goes through or something that moves off. It's just a matter of how many hours you park it.
Yeah.
I think any 1 hour of this was reasonably close to normal.
I don't have any herd data. I don't know if anybody looking at any mesoscale data, but my understanding is nothing really had a clue of how bad this was going to be.
I didn't look at it exhaustively, but I did see an HRR run on the night, the afternoon before the event in Florida, that had a over 10-inch, 15-hour amount.
Oh.
But it was a bit southwest. It was just out over the Gulf.
Oh. So it had a clue. It was in the ballpark.
Yeah.
And we have to calibrate our forecast, realize that this means that we're in the neighborhood where that is. We seem to say, well, the low is going to be here, so we forecast the weather like this, but the low could be here. We don't account for that uncertainty. So there was uncertainty of that, in the fact that the model had a hint that it was going to be a massive rainfall event, but it had no clue where. That probably was one of the better heads up, I guess. I didn't see that particular run. But it was an interesting event. So, anybody else? So the coming weather, we're going to have a mean trough as opposed to a nice one stuck over most of the eastern United States for the next 1 to 7 days. Our precipitable water remains most of the time it's actually near or below normal. We don't get any major surges of moisture, so that should limit our precipitation. And if you look at the probability distribution functions, one of the things I've really come to think about when we look at plumes, we look at probability of QPF amounts with any probability of any threshold in an ensemble. We see, especially when it's QPF, we seem to think it's a probability of precipitation, but it's really just an expression of the probability distribution function of the ensemble forecast system. It's not even close to being a pop. Sometimes we treat it like a pop, and it really isn't. And if you do, you're going to crash and burn a lot. Trust me, I've been there. But anyway. We have to treat these things just like a PDF out of the ensemble forecast system, not a pop like we think about in MOS. That might temper our forecast. But basically, I'll show you in a little bit, there's no hints of any major precipitation events for the next 8 days, but we still kind of trough the next 1 to 5 days, and then the flow gets really weak, so the weather should gradually improve. And then the models actually, the ensembles show a pretty good ridge building in the southeast United States, which would imply we're going to have a late season warm-up. Some of the kids getting drunk next Thursday before finals are going to have some nice weather, maybe. Oh, I wasn't supposed to say that. But anyway, there's a potential warm episode coming up, which will make anybody here graduating. So So it could be fun. Like, don't sit in the sun. Don't drink in the sun and fall asleep. Like, I learned that when I was in high school. Go up Long Island, go to the beach, get drunk, fall on the beach and sunburn, and then you're dying for a week. But anyway, this is the SREF forecast, and the SREF actually had some light precipitation over State College earlier this morning, and then you see it's pretty dry, and then it's putting out really paltry amounts of precipitation. For the weekend, but it's all over the place. It's basically light stuff. And if I've been trying to look at the precipitation in a lot of these models, but they really put out a lot of low-end precipitation sometimes. So the low-end amounts they tend to be wet. So, and this is the temperature profile. And if it's sunny outside, I usually add 5 degrees for the highs out here. These 2-meter temperatures really under forecast high temperatures. But it looks like we should be in the 60s today. Probably if we can keep the sun out, probably push 65. It says, but. Nights kind of in the 40s, and it looks pretty quiet. It looks like the model thinks we're going to have almost a classic, relatively normal diurnal pattern. There's some crazy run here that's all by itself. I don't know, this looks ridiculous to me. 2-meter temperatures the 50 temperatures all by themselves there. But pretty good agreement between all the SREF members in general. There's nothing exciting happening. And this is the GEFS, and the thing that jumps out at you is it looks like the SREF with the nice daily stuff. And it's amazing for an 8-day forecast how the 2-meter temperatures are pretty well aligned. You can see we start getting some spread at 850 here, and it gets a little worse out here. So it's how fast that ridge builds in. So obviously you want to do a more probabilistic forecast out there, because the black line is the black line is the mean, and the thick yellow line is the median. The median is actually displaced initially a little bit colder. When it finally starts to warm up, the median is actually colder than the mean, so there's really warm members, and then it flips. So there's more warm members, there are cold members. So, but it's basically saying we're looking for a warming trend late next week, and but it doesn't look really exciting, not particularly cold. And you can see little bumps in the precip, but nothing. The dribbles that the models seem to kick out forever. There's one model where that apparently was cold because there's a blue period of snow there, and one of that's ridiculous. But there's really nothing great. I mean, in a period of 8 days, like the mean QPF is about an inch, which is probably not really all that exciting, but. So let me switch here. F11, as opposed to F111. Yeah, these are the plume diagrams I showed you. This one's for Allentown, but we go to State. Oh, I had this one on. I'm sorry. This is on specifically. This is Allentown. This is a GEFS run from the 26th, and you can see that for our precipitation event, it kind of showed this prolonged precipitation event with a sharp increase of precipitation, like around 0Z on the first, which was last evening. And there was a wet member there showing about almost 5.5 inches of rain. But the mean was about 341, and the max was 541. But it was a pretty wet solution. It was pretty good agreement. And I guess that's just the forcing, I guess, in the GFS, because it just has the perturbations. All the models kind of perform, all the members perform about the same. But it was a pretty good forecast if you lived in Allentown. But if you looked at State College, you might not be as thrilled at what it looked like. I mean, we didn't come anything close like that to the precipitation. It's funny, there's clearly a cold member in this one that was out around the 4th and 5th too. Look at that. But we didn't come close to this precipitation. We had less than the min. That's why we really need calibration diagrams when we forecast to know, like when there's what percent of the time the model forecasts an inch of rain that we actually verified inch of rain. It's pretty bad. I've seen some calibration for the SREF, and it's pretty bad. So we go open a tab. So, but this is the 27th, and this shows the probability of 4 inches of rain. Most of the models are forecasting the heaviest rain over the DC area, but they've actually caught on to keeping it along the coast where most of the rain fell, just where the max was going to be. But the GFS did generally a good job on the general area. The details were something that took a long time to hone in on, and we ended up being on the edge of it here clearly with Lancaster County. Eastern Lancaster County got a lot of precipitation. So now we'll move to the current weather. What do you think the odds of 12Z is in? The odds might be pretty low. Best 6Z will do us, right? So let's look at the large scale pattern. Look up all of North America, and we'll actually look at 500. Where the heck the Pascals is 500? So anyway, here's the large scale pattern valid at 6. This is the 6Z. You can see the deep trough. A lot of anomalies Nice huge ridge along the west coast, a couple of troughs. It's that time of year you get a lot of cut-off lows. And you can see the sharp, what's left of our blocking ridge along the east coast goes all the way up into Hudson's Bay. So we'll just step through this in 6-hour increments. And the trough, we're still troughy. This is tomorrow. Our heights begin to slacken off by Saturday. Still a huge ridge out over the Atlantic. And you can see a kind of a progressive hydronomial ridge in the southern stream over the southwest. And finally, by Monday, our heights are they're still slightly below normal, still trophy, but now we're getting the northwest flow. So we should theoretically maybe dry out, although really strong northwest flow is a bit severe weather type for us if we have moisture, but this doesn't seem to have it. And then everything gets kind of quiet. Everything's normal. And then this is Wednesday. You can see the ridge building. It's building up in the southeast United States. And then we start getting positive height anomalies over the southeast United States. So, you know, if this verifies, which I'm not saying it will, because it's a forecast, and you can see there is some spread up in here amongst these members. But the general pattern is that we're looking for some building heights next week. How long it's going to persist is anybody's guess. As longer range forecast. I look at the 850 temperatures, and I'll have to go to the eastern scale. Because we live locally, we want to see it locally. So you can see we're supposed to be just slightly below normal, 850 through about Saturday, which will hardly help some shower activity in our area. Pretty quiet, little weak system comes by on Saturday night, Sunday. Another weak system comes by with some reinforcing slightly cooler air overnight Saturday to Monday. Finally, we start building some warm air in the southern United States. And by Thursday, we could have an abnormally really high temperatures at 850. We'll probably be slightly cold air dam, but nothing's perfect in life. But this pattern doesn't actually support us being really well cold air dam because the anticyclone's to the south east. So we have a shot at warming up. But if we look at the precipitable water plumes, I'll do this on the U.S. scale. It's probably going to change variables on me, but because we just had a really tough week with severe weather and flooding. And you can see the blue zone is for loading and unloading dry air parcels. And you can see the central United States is really kind of in the blue, so it's really good. And we'll go all the way into the weekend. They stay dry, so there's no fuel for any severe weather or any heavy rainfall in the central part of the country, even for us. And our first hints of moisture don't really come by. There's a weak thing that comes by on Tuesday, but it's moisture starved. The Gulf of Mexico is completely dry. It's cut off, so any moisture is really long trajectory moisture. We get a little bit above normal moisture right in here on Wednesday, but this is not a pattern that says we're going to have significant rainfall. So like those Gfs plumes of the inch and a half of rain are probably ridiculous. But finally, the Western Gulf opens up next Friday as that ridge, which you'd expect when a ridge is building over the eastern United States, but it's not completely open, so it doesn't look really impressive. If I go to the probability of, say, any 24-hour having an inch of QPF, and unless you live in Florida, it's almost as dry as my sense of humor. So it takes until maybe Friday to get something going in the central part of the United States as that moisture plume that we saw gets started up. So just for grins, we'll see if this says anything on it. So that's what the pattern is supposed to look like on May 17th. So let's look at the evolution of our ridge next week. You can see it starts out really, this is the 16-day run of the GFS, but it's bias corrected, and you can see the pattern gets pretty quiet by the 6th. And that ridge, looks like that ridge goes through the 9th. So that ridge off the East Coast looks like a persistent feature through May 11th, through next weekend. So it looks like we could have a couple of warm days here next week into next weekend. So nothing really exciting. We can end up with a trough in the east, but this is like we're in Never Never Land where the models have very low skill, but it's fun to wish. So let me switch back. Need that little guy to come up at the end of the cartoon. So in summary, we had a strong trough that came through the central part of the United States. It brought a nice surge of moisture into the central part of the country. It was blocking probably to our northeast. That slowed the frontal system down. So it created a really good 2-day severe weather event. We had some fatalities, and we had a couple of really powerful, strong tornadoes. We had major flash flooding in the southeast, mainly in Florida. We had some pretty good rains with some isolated flooding on the East Coast. And It was all due to the same slow-moving system that just kind of chugged through. Looks like we're going to have some generally unsettled weather because we're going to be generally troughy for the next several days, but there's nothing we can put our hands on and say we're going to have a good rain event. It's going to be just showery stuff and probably won't ruin most of your days. There's nothing big in the cards at this time. And clearly we discussed the models had a huge QPF bust in the southern United States, and they had a fair QPF bust here in the east. And looks like maybe a warning trend for next week. So anybody have any alibis, questions, or comments? Because if not, that's all, folks.
Questions? Anybody?
Answers.
Yeah. All right. Well, thank you for another great semester. Let's thank Rich. Now we can move on to summer. Right. Get finals. Yeah, no problem.
When he said summer, I thought that little snowman news. Wants to get a tan on the beach? How do you get a snowman tan? I graduated from high school when I was 17. What are you doing today? I have nothing that really we've done a lot.
No problem, Bill. On to next year. Hey, I'll send out the email next week. Well, he emailed it to me today, so I had class. But yeah, either way, you're going to come next year. Yeah, well, if you're ever interested, we're happy to have one.
Summer, winter, spring, summer.
I don't know how it goes.